Hey guys, Zong here, back with another math video. Today we're going to be doing AIME problem 15 from 2012 AIME 2. And yes, it is problem 15, so please don't be ashamed if you can't solve it. I came nowhere close to solving it because I suck at math. So just look at the problem. Make sure you really understand the problem. Try to draw a diagram by yourself. Even the diagram is just hard to draw, so, yeah. So here's the solution. Let's get started. Let's draw the diagram first. So, actually, you know what? Let's scroll down because we need room for this diagram. So here's a circle, and of course you want to draw the triangle. So let's draw the triangle. That's going to be 3-side AC. That'll be AB, and if I can just draw this, so alright, we have a triangle. Let's just label the sides. Now let's draw the angle bisector. It's around there, I think. And we're gonna need this. Oops. We're gonna need these lines later, so I'll draw them now. And let's draw that circle from DE. Oh, frick. Oh man. All right. Now let's label them. D, E, F. Let's draw a line from A to F. Now, I would normally draw the diagram before the video, but I feel like part of the problem is just drawing the diagram. Drawing the diagram is hard enough, and I feel like that should be part of the problem too. So here's what the diagram should look like. Hopefully this is what you got. It's around what this. So this is, since it bisects, since AE bisects angle A. These two angles are the same, so let's just label them theta. And we use the angle bisector. Now, this problem requires a ton of steps, right? I can't explain every single one thoroughly and completely. So, first of all, use the angle bisector theorem to solve for CD and BD. The angle bisector theorem basically states 5 over BD equals 3 over CD. And then CD plus BD equals 7, and then you use that system equations. So okay, BD over 5 equals CD over 3, and then let's see. So CD plus BD equals 7. Alright, you have two system equations. You get, I believe you get CD equals 21 over 8, and BD is 35 over 8. So, 21 over 8, 35 over 8. And then you want to find AD. We had a few videos on Stewarts Theorem, but you have to use Stewarts Theorem. And if you don't know what Stewarts Theorem is, I invite you to go watch our video on Stewarts Theorem, proving Stewarts Theorem. It's an identity that's useful for finding if you draw on line A a cVian from A to like the line BC, you can actually find the length of that cVian, in this case AD, based on the lengths of CD, BD, AB, and AC. And that's Stewarts Theorem. And I can't explain it right now because it takes a long time to explain the theorem, but basically, if you go watch our videos on Stewarts Theorem, you find that AD equals, I think it equals 15 over 8. So please, I hate the feeling of not knowing that I wouldn't be able to get a problem because I didn't know a certain theorem. So just please go watch the video. It's very useful in AIME, and AIME is coming up. I hope you guys all did well in AMC, by the way. So 15 over 8. We use power of a point from this point. And power of a point basically states that BD times CD is the same as AD times DE. And so 35 times 21 equals 15 times DE over 8. So you get DE equals 49 over 8. And then you get that this thing is 8. If you add 15 over 8 plus 49 over 8 together, that's 64. So that entire line AE is 8. And so we have all these lengths. What next? Now is time for the really annoying part. Now is time for some it's where you deal with angles, basically. Alright, now don't worry, there's no trigonometry. There is trigonometry, but there's only a tiny bit. The only trigonometry you need to know is law of cosines. And law of cosines right in the top right is if you have A, B, C, angle theta, C squared equals A squared plus B squared minus 2AB cosine theta. That's law of cosines. Let's use law of cosines to find theta in here. So 21 over 8 equals 3 squared plus 15 over 8 squared minus 2, 3, 15 over 8 cosine theta. And you eventually get that theta is pi over 3, which is 60 degrees. We're gonna work with radians though, because it's better to work with radians. So that's about 60 degrees. So actually, let's just work with degrees. So theta is 60. So 60 degrees. So okay, this seems to be a cyclic quadrilateral. ABEC is a cyclic quadrilateral. So you know that this is equal to this. So this is 60 degrees as well. Same here. And we know that BEC is actually equilateral. So which means BE is 7 and CE is 7 as well. Okay. Now that we know this, let's keep going. So I'll have to scroll down a tiny bit. Oh shoot. I'm running out of room. Sorry. So let's keep going. So we use law of cosines again, show that in terms of AEF this time, and we know that AE squared equals AF squared plus EF squared minus 2 AF EF times cosine AFE. Oops, that's an F. And then AF squared equals AE squared plus EF squared minus 2 AE EF cosine AE. I think it's AF. Wait, is it? Yeah. Sorry, it's cramped, man. Alright, we got this stuff. Let's add them together. Let's add these two equations together. And I'm not gonna do all the math here, but if you add these two equations together, sorry, let me just delete some stuff here so I have more room to work with. If you add these two things together, you simplify it. So AE squared plus AF squared. You see that if we add these two equations together, we get AE squared plus AF squared on both sides. Subtract them, we get 2EF squared minus 2AF EF cosine A. Yeah, if you simplify it, you get this equation, which is EF equals AF times cosine angle FE plus cosine angle AEF. And we'll use that later. For now, let's look at something. So we noticed that so ACE is actually equal to angle AFE. And it's because they're the same arc, the angle of the same arc. So ACE, this angle is equal to angle AFE. So what's cosine ACE? We can use that using law of cosines. That's just so we use some algebra. So AE squared equals 3 squared plus 7 squared minus 3 times 7 times 2 times cosine ACE. So we know that cosine ACE equals cosine AFE, and cosine ACE, if you calculate it, is negative 1/7, and you calculate it using law of cosines again, and negative 1/7 equals cosine AFE. Alright, make sure you've written that down because I'll have to erase a lot of stuff to make some room. So this is equation 1, this thing right here. Don't worry about this one. And this is equation 2. Alright, so when I refer to them as equation 1 and 2, you'll know which equations I'm referring to because I'm going to erase these right now. We'll soon. So now that we found that, let's keep going. So we know that cosine AFE is negative 1/7. Now let's see. What. So DEF, the angle DEF is equivalent to angle AEF, and DEF. Okay, let's draw another line. Since DE is the diameter of the circle, so D is the diameter of the circle. This is a right angle, which means that DE. DE, cosine DE, I should say, cosine DEF, I should say, sorry, is equal to, I believe, EF over DE, which is also equal to cosine AEF, because they are the same angle. Okay, so now we have all this. Let me see what to do next. So we can sub in DE, since we know DE is 49 over 8, and we get that cosine AEF equals 8EF over 49. Alright. Now we have everything we need. Let's sub all these values in, because we know that, okay, let's sub these values in to our equation number 2. So cosine AEF we just found is 8 over 49 EF, and cosine AFE we found is negative 1/7. So if we sub this in, we get, oh, whoops, I forgot something. This is EF times, this is cosine AE times this. Sorry about that. It's such a hard problem. I'm getting really flustered here. Actually, let's go to the left. So if we sub that in, if we sub cosine AEF in and cosine AFE in, we get that EF equals negative AF over 7 plus 8 times 8EF over 49. Alright, we have that. So what exactly is EF exactly? So we have EF on both sides, and we can put EF in terms of AF, and we get that EF equals 7 over 15 AF. And what do we do next? We have this, pretty freaking close, I'd say. We'll sub that into the first equation. And when you sub all this crap into the first equation, you get, so we know AE, right? AE is 8. So you get 8 squared, and first equation is this thing again, this thing. You get 8 squared equals AF squared. Remember, you sub in everywhere where EF shows up. You sub in you put EF in terms of AF. So everywhere where EF shows up, you can sub in AF. And also cosine AFE, we know cosine AFE is negative 1/7. So you actually get this thing. So you get everything in terms of AF. Squared minus 2AF times 7 over 15 AF times negative 1/7. So 64 equals AF squared plus 49 over 7, 25 AF squared minus 2af times 7 over 15af minus 1/7. And then you get you get everything in terms of af squared, and you get af squared equals 900 over 19. And 900 plus 19 equals 919. So there's our answer, a small, tiny answer. And so the answer is 919. Sorry I stopped so much. It's if you look at my note paper, it's just a huge mess because there's so many equations to write down. But even though this looks like a tricky problem, the only real trigonometry we did was just a crap ton of law of cosines. So though a problem may seem tricky, just know that law of cosines, like most geometry problems won't contain all that much trigonometry. This is number 50, and it didn't contain that much trigonometry. You only need to know one trigonometric equation. However, you did need to know a lot of theorems about triangles and geometry in general, like power of a point, Stewarts Theorem. The main reason if I actually knew how to solve this problem, like the way to solve this problem, I probably wouldn't have gotten it because I forgot Stewarts Theorem. So just memorize your theorems, memorize your geometric properties, like properties of cyclic quadrilaterals, stuff like that, and you should be fine. So I hope you found that problem interesting, and I'll see you next week.
So you can first try to prove it by yourself. Alright, ready? Let's begin. So first, when using vectors, I'd like to set an origin. It's not necessary, but it's nice to have an origin. So in